Hi dear students, எப்படி இருக்கு? So we are coming to our final touch series, okay? So final touch series by Brainiacs Classes. So here we discuss the important questions from each chapter, and that is completely purely based on NCERT, okay? So whoever feels interested, okay, they can watch the video. I will also update this particular PDF as a link in our YouTube channel, okay? So enjoy பண்ணுங்க. It's very superb. Almost all important questions I have taken. Okay. So regarding Brainiacs Classes, as you know, it is one of the best Neet coaching center in Coimbatore. We have we have delivered around 100 plus doctors in our past 4 years. Yeah, that's it. So let's start with our first question for the day. I hope you could see it. If you have any doubt, you can put as a comment in the comment box. So the first question from the chapter hydrocarbons. So the question here is the reducing agent in Birch reduction method is. So we know Birch reduction is a method where we convert an alkyne, a triple bonded compound, to a double bonded compound. Okay. So which is the reagent used during that process? So please understand, we use sodium in liquid ammonia. And the most important thing with respect to this Birch reduction is what actually? Here, during the process, an alkyne, you can see an alkyne is taken, a non-terminal alkyne, it is getting converted to an alkene, but we can see the product obtained is a trans-alkene. Trans means what? The heavier groups are on the opposite side. So this is one method where you can prepare trans compound from an alkyne. Okay, so the method is Birch reduction. Okay, it is sometimes also called as dissolving metal reduction. It is another name for Birch reduction. So answer is which one, sir? We have many other reagents given. So the answer for this particular question is which one? Tell me, sir. Answer is option 4 is the correct answer. I will take a red ink. Okay, so I hope it is clear. Now we'll go to the next question. The question here is addition of HBr. You can see the question, I hope. Addition of HBr to 2-methyl-prop-1-ene in the presence of peroxide mainly forms. This is the question. So you can see here it is 2-methyl-prop-1-ene. 1, 2, 3. So you can see it is 2-methyl-prop-1-ene. You are treating this with HBr. Okay, but please remember, when HBr comes into picture, you need to consider two things, whether it is with the peroxide or without peroxide. So you can see here a peroxide is given. How you know it is a peroxide? Because this indicates peroxide linkage. Okay, they can give it in any ways. So whenever this peroxide linkage is present, we can say this is a peroxide. And what is the mechanism followed here? It is free radical addition reaction, FAR, free radical addition reaction. And what is the fundamental rule that is followed here? It is anti-Markovnikov's addition. Anti-Markovnikov's addition means what? You have positive addendum as well as negative addendum. The negative part of the addendum will go to most hydrogenated carbon atom. That is called anti-Markovnikov's rule. So Br will come here and H plus will come here. Okay, so you will get a compound that is CH3. You can see here CH, CH3, CH2Br. So what is the name of this compound? So I can choose the parent chain like this. You can number it 1, 2, 3. So I can say 2-methyl, 1 bromo. So alphabetically bromine will come first. So I can easily say 1 bromo, 2-methyl propane. Okay, why it is propane? Because all are single bonded. So which is the option, sir? Tell me. I hope all of you are preparing well for the exam. Okay, so prepare well. So we have this final touch-up series coming continuously with each chapter, and that will surely help you to crack the Neet with very good marks. Okay, so please don't lose the hope at any moment. Please continue, please prepare continuously. That will give you success. Okay, so let's go to the third question. The question here is, you have a propene given here, and again it is treated with the HBr in the presence of peroxide, and that will give you a product X, and this on further treatment with sodium in the presence of ether is giving you another compound Y. We need to identify what is Y in this compound. Okay, so we have propene here. Again, you know, with HBr, with the presence of peroxide, it is nothing but free radical addition reaction or Markovnikov's anti-Markovnikov's addition. So what will happen? The negative part of the addendum will go to across the double bond. You can see this is the most hydrogenated carbon. So the negative part of the addendum will come to most hydrogenated carbon. So CH2Br will come and hydrogen will go to the other carbon atom. So you will get a compound that is nothing but, you can name it 1, 2, 3, 1 bromopropane. Okay, but they are not asking you regarding X. They are asking you what will happen. It is further treated with sodium in dry ether. We know sodium in dry ether is nothing but, here Wurtz reaction is happening. Wurtz reaction. You know it actually, Wurtz reaction. So what will happen? We take 2 alkyl halides, because for performing Wurtz reaction we need 2 alkyl halides. Then we are treating it with the sodium. So what will happen? Here free radical mechanism will happen. The bond will break homolytically. You have sodium with 1 electron here, another sodium with 1 electron. So this NaBr will donate 1 electron, Na will donate 1 electron, and they form NaBr. And these two free radicals, these two will combine each other, so that you will get the first half combining with the other half. So you will get normal hexane. Okay, normal hexane would be my product. So which is the option, sir? Tell me fast. Now it's a time we need to go a little faster. So option 3 would be my correct answer. So we'll switch to the next question. I hope all of you could see here. The question here is, which among the following groups, when attached to the benzene ring, will direct the incoming electrophile predominantly to the meta position? So here you need to know some fundamentals. So when in benzene ring, when substitution is present or some group is attached, that group can decide the incoming electrophile either to be at orthopara position or at meta position. This depends upon what? So please remember the fundamentals. We have orthopara directing groups. Orthopara directing groups are generally plus M groups. That means which show plus resonance. Usually how you can identify this? Whenever there is a group that is having a lone pair attached to the atom which is connected to benzene, then mostly it would be what? It would be orthopara directing, exception NO2. Here how you can say that is, how? Because you also need to check the surrounding atom. In this case, the surrounding atom would be less electronegative compared to the other. For example, here you can see when I am comparing nitrogen and hydrogen, nitrogen is more electronegative than hydrogen. You can see. Here also you can compare, you can see nitrogen more electronegative than hydrogen. Here N and R, alkyl group, nitrogen more electronegative than alkyl group. Here also N more electronegative than hydrogen. And here you can see oxygen more electronegative than hydrogen. Here also oxygen more electronegative than alkyl group. So mostly the atom which is connected to the benzene will be more electronegative compared to the surrounding atom. Okay, this is the fundamental you can remember about plus M group. And meta directing groups, they are called minus M groups. Minus M groups, they are called deactivating groups. Okay, what is the reason? Because it will pull the electrons from the conjugated system. Why it is happening? Because in a meta directing groups, you can see here the first atom will be less electronegative than the neighboring atom. Oxygen more electronegative than nitrogen. Here you can see carbon less electronegative than chlorine. Here carbon less electronegative than oxygen. Okay, here CONH2, carbon less electronegative than oxygen. Here also carbon less electronegative than oxygen and chlorine. So you can see that. So the fundamental is in a meta directing groups, we have atoms that is connected to benzene, but the neighboring atoms will be more electronegative than the connected atoms. So with this fundamental, you can easily answer this question. If you see here, which among the following groups when attached to benzene ring will direct the incoming electrophile predominantly to the meta position? So to the meta position, which group will direct? I can easily say minus M group. Okay, because when minus M group is connected, the system will have what charge circulating? Positive charge will come at orthopara position. So comparatively, electron density is more at meta position. So the incoming electrophile will attack at the meta position. That is the reason why minus M groups, when connected to benzene, the incoming electrophile will come to meta position. So what is the answer here? So first one will not come because carbon and CH3, you can see it has plus I effect and it will activate benzene by hyperconjugation also. The next one you can see oxygen and carbon. Oxygen is more electronegative. So I can easily say this is an activating group. NO2, I told it's an exception, but you can see here oxygen is more electronegative than nitrogen. That means surrounding atom is more electronegative. So that means this is a deactivating group. Here CCl3, chlorine, more electronegative than carbon. So that means this is also a deactivating group. In NHCOCH3, nitrogen more electronegative than hydrogen. So I can say 3 and 4. My answer here would be option 3 and 4 would be my correct answer. Clear? So it's very simple. So let's switch to the next question. You can see the next question here. Which of the following alcohols undergoes acid catalyzed dehydration most easily? That is the question. So here we know alcohols, it can undergo two types of reactions. One is they have nucleophilic substitution reaction, other is elimination reaction. So here dehydration, it's a type of elimination reaction. So if you see in the NCERT textbook, the ease with which a dehydration happens here is 3 degree alcohol followed by 2 degree followed by 1 degree. But sometimes in the options there will be more than 1 3 degree alcohols are there. In that case, how will you find out the answer? Very simple, sir. We need to understand the mechanism. Usually dehydration, it happens in 3 steps. It's not 2 steps, it is in 3 steps. Okay, it usually happens in 3 steps. So what are the 3 steps? First one is protonation, then we have formation of carbocation, and the third one, the removal of alpha hydrogen as H+. We will see the mechanism, then you will easily understand. Okay, so in the first step, in alcohol, we know it's a very strong nucleophile. It is strongly connected to carbon. So if you want to remove the OH from the carbon, you need to remove it after making this species unstable. For that, always what we do protonation, that is attacking with H+. So once H+ comes here, oxygen will gain positive charge. So what will happen? This pair of electrons will go to oxygen. So what will happen to this particular bond? The electron density, I can easily say, it will increase near oxygen atom and it will decrease near the carbon. So automatically this will undergo heterolytic fission. I can easily say that. Then you will get a carbocation. I can say, I hope you could see it actually. Okay, I can say this step from alcohol to this carbocation formation, it is the slow step, and hence we call that is the rate determining step. Then what will happen? Once this is there, we can say this is alpha hydrogen, this is alpha carbon. So there are 5 alpha hydrogens are there. So I can say this hydrogen will move out as H+, and this pair of electrons will come here as a pi bond, you can see here, and hence the product formed here is this one. This is the fundamental mechanism. Now regarding this question, how to answer it? So here we need to see which alcohol is undergoing dehydration most easily. So we need to identify the rate, or we need to say which will form the product very fast. So we know the first step as the rate determining step. So whoever can form the carbocation very easily, that guy can form the product very easily. So if the carbocation is stable, then only the first step will come to this particular one. I mean the reactant will become carbocation very easily if the carbocation is more stable. So we need to see from the given options which among the following can form a more stable carbocation more easily. So from this I can say option 3 would be the correct answer. Why? The reason is, you can see here when OH is gone here, you will get a positive charge here. You will get a positive charge, and that is in resonance with the phenyl group, and there is CH3 here and another CH3 here. So 6 alpha hydrogen through hyperconjugation also this species will become more stable. So if you see the relative rate, I can say first who will come? This one, what we have chosen, then this one, because here we have phenyl with the CH3, and here you have 3 CH3 group is there. So 9 alpha hydrogen will make the system stable, but here benzene is also present, so resonance is also present. Finally this will come. Okay, now next go to the next question. The conjugated double bond is present in, it's a very simple question. So first one we can see propylene, there is no conjugated double bond. Next one isobutylene, iso means this should be present, butylene means there are 4 carbon atoms, lene comes because there is a double bond. Okay, there is no conjugated double bond, but when we see 1,3-butadiene, you can see here conjugation, double bond, single bond, double bond. So this is my conjugated diene. So my answer here is which one, sir? Tell me, sir. So my answer here is option 3 would be my correct answer. I hope it is clear. Okay, now let's go to the next question. The question here is, this is an alkyne which is treated with a red hot iron tube at 873 Kelvin. You are getting A. What is that? It is nothing but our aromatization reaction. Aromatization, or I can say it is a method of preparation of what? Benzene. So you know benzene have 6 carbon atoms. Correct? So usually how many alkynes are required? I can say 3, because one alkyne molecule can give you 2 carbon atoms. So when 3 alkyne molecules are treated at a high temperature in a red hot iron tube, you can easily undergo aromatization and you will get benzene. So my answer here is which one? Option 3 would be my correct answer. And please remember, sometimes they may give propene also. Propene also you can get. So in that case, you are taking 3 propene molecules, there you will get a special compound that is called mesitylene. Because 3 moles means total 9 carbon atoms. So there are 6 carbon atoms in benzene. Along with that, another 3 here it is present. Clear? So let's go to the next question. You have a question, this is very important. I am expecting for this year's Neet exam. Very, very, very important. Okay, directly from NCERT. The question is, a hydrocarbon with the molecular formula C8H18. Okay, let's see. A hydrocarbon with the formula C8H18 gives only primary monochloro derivative. Identify the hydrocarbon. Very simple. So we need to do option elimination here. Why? Normal octane. If you see here in a normal octane, we have 2 types of carbon, primary carbon and secondary carbon. So if you are substituting chlorine here, either at primary position, you can see you will get 1 monochloro derivative. But if you substitute at the secondary carbon, okay, 1 minute, if you substitute at the secondary carbon, what will happen? You will get another monochloro derivative. So surely I can say this is not the correct answer, because we need to get primary monochloro derivative. Second one, 2-methyl pentane. So if you see 2-methyl pentane, you can see this is the structure actually. Here also, if you substitute chlorine here, you will get 1 compound, and if you substitute chlorine at here, you will get another compound. So that is also not the correct option. Then we will go 2,2,4 trimethyl pentane. So if you see here also, there is no symmetry in the compound. Please remember, if you want to get a monochloro derivative, usually the compound will have some sort of symmetry. So that's the reason I will go for the option 4 without even doing it. Okay, so if you see in the 2233 tetramethyl butane, you can easily see there is a symmetry present in the compound. So I can say, if you put chlorine anywhere here, okay, if you put chlorine anywhere, here, 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 here or here, you are going to get the same compound. So I have shown here, you can take a screenshot. If you put chlorine here or here or here or even here or even here or even here, you are going to get the same compound, that is 1-chloro-2233 tetramethyl butane. So that's the reason I am choosing the answer as option 4. Clear? So let's go to the next question. Again, this is regarding aromaticity. Okay, the question here is, which among the following is aromatic in nature? So we know a compound, if this needs to be aromatic, it needs to follow 4 main conditions. One is cyclic, it should be planar, it should have cyclic resonance, and the 4th one, it should have 4n plus 2 pi electrons. So here the first species I am taking. Okay, here the first species I am taking, from theming itself I can say double bond is present, then single bond, single bond. There is no conjugation after this one. So that means there is no cyclic resonance here in the first one. Second one also you can see, whenever 2 single bond is coming continuously without any charge, I can easily say there will be lack of cyclic resonance. So this will not be aromatic. Then the third one, you may get a doubt, because here the compound is cyclic in nature. It is planar. Why it is planar? Because each carbon atom have sp2 hybridization. Why it is sp2 hybridization? If you see here, there is hydrogen atom, here S, this is P and this is P. All sigma bonds, if you see 3 sigma bonds are there, that means this carbon atom is sp2 hybridization. If sp2 hybridization is present, that compound will have a geometry trigonal planar, hence it would be planar. But this compound, aniline 10, it's a special compound. Why? Because in this case, the hydrogen atom that is present here, all the hydrogen atom will undergo repulsion. That's why its planarity would be lost. So that is the reason why this is non-aromatic due to non-planar nature. Very, very important. Then the final one, that is an NCERT option, is nothing but our tropalone. Some students may feel a doubt like, sir, in tropalone, if you see double bond, single bond, double bond, okay, single bond, double bond, then 2 single bonds are coming, sir. So there is no cyclic resonance. Some students used to say, but please understand, this is a carbonyl group. Carbonyl group means oxygen is more electronegative than carbon. So most of the time it will undergo polarization, negative and positive charge come here. Now if you see, there is conjugation is present. Okay, and if you look at each carbon atom, each of them would be sp2 hybridized. That means it is planar in nature. And if you count the number of pi electrons, 2, this is 4 and 6 pi electrons are there. In 4n plus 2, if you put n is equal to 1, you will get the same 6 pi electrons. That means it is following 4n plus 2 pi electron rule. So I can easily say my answer here would be which one, sir? I can easily say that would be tropalon. Okay, and regarding anti-aromatic, some students used to ask this condition, but it's not mentioned in NCERT. Same conditions are there. The only exception is instead of 4n plus 2 pi electron, we need 4n pi electron. That is the only difference. Okay, and if you see the stability, I can say aromatic is more stable than non-aromatic. Non-aromatic is more stable than anti-aromatic. Okay. Now let's go to the next question. It's an important reaction with respect to benzene. Benzene react with chlorine in sunlight to give a final product. Please remember, in the presence of sunlight, benzene will undergo free radical addition reaction. So what will happen? Excess of chlorine molecule is there. There will be Cl dot would be created. That will be added across each pi bond, and one chlorine will come here, another chlorine will come here. So similarly, 3 moles will be used and you will get a compound like this. If you see this compound, this is C6H6Cl6. That is nothing but my option 4 would be the correct answer. Please remember, sometimes they can ask this question chlorine with a Lewis acid like aluminum trichloride. So there what will happen? Cl plus electrophile will come into picture, and here instead of hydrogen, chlorine will come. Here all hydrogen would be replaced with the chlorine. So what will happen? In that case, the formula would be C6Cl6. So please remember the reagent. When chlorine is there, don't jump to the conclusion. Check whether UV light is present or a Lewis acid is present. Okay. So let's go to the next question. The question here is, electrolysis of an aqueous solution of sodium acetate yields what? So sodium acetate is what? We know electrolysis reaction is mentioned in NCERT. So whenever electrolysis reactions, those things are coming, Wurtz reactions are coming, take 2 species. So what will happen in electrolysis? Carbon dioxide is eliminated. So remove carbon dioxide. So, and remove sodium from here. So what you will get? 2CH3 dot, free radical mechanism. So this 2CH3 dot will combine like this and you will get an alkane. Or easily you can say, take the hydrocarbon part alone, removing the carbon dioxide, and combine, you will get the product. So here what you are getting? Ethane would be my correct answer. Clear? They can give the question like anything, but remove the hydrocarbon part, put dot there, take 2 molecules, combine, you will get the final product. Okay, so in anode here oxidation happens, and in cathode we have reduction. Now go to the next question, all of you. The decreasing order of reactivity towards ESR, electrophilic substitution reaction, of the following compound is. So here also we need to understand our fundamentals. Always plus some group activates the benzene, minus some group deactivates the benzene. Just to see that here NO2 group is there, we know it is a minus M group, and minus I effect is also present. CH3, we know it is having hyperconjugation and inductive effect that will activate benzene. Here chlorine, it's an exception. Even though it has plus some effect is present, its minus I effect is greater than plus some. So that's why it will deactivate benzene. Okay, so please remember, plus M and plus I group activates benzene towards ESR. Exception is halogen. Halogen, even though it have plus some effect, but its minus I effect is more than plus some effect, so it will deactivate benzene. So, and please remember, CH3 always activates benzene not through plus some effect, but through hyperconjugation and inductive effect. So my answer here would be which ones are? I can say first CH3 will come into picture, mostly activated, then benzene, then chlorine, it will deactivate benzene, and NO2 it will deactivate. Among this, chlorine have minus I, this have minus M and minus I. That's why it is getting deactivated to the maximum. So my answer here is which ones are? Option 3 would be my correct answer. Clear? I hope you are understanding. Okay, I'm going little fast so that we can handle more questions. So we have the next important topic, that is ozonolysis. We have separate videos in our Brainiacs YouTube channel for ozonolysis. So those who are watching the channel for the first time, please go through our playlist, revision videos. All important concepts are handled there. Okay. And please feel free to subscribe the channel. You will get continuous questions as videos, and also in our community we post daily 10 organic questions. You can answer it, and all those questions are purely from NCERT, purely made from our side. Okay. Let's go through the question. Ozonolysis of 1,3-butadiene gives. So I told whenever this is 1,3-butadiene, you can see here. And for ozonolysis, I told one shortcut. What you need to do? Remove the double bond completely. Then what you need to do? Distribute oxygen on both sides. Or first you distribute oxygen on both sides, then remove the pi bond. Remove the double bond completely. So here this will become HCHO. Okay. Here also this will become HCHO. Then here you can see here oxygen at both sides. CHO, single bond CHO. You can see here. So you are getting first one 2 moles of formaldehyde and glyoxal, 1 mole of glyoxal. So my answer here is what? All these are aldehydes. So I can say my answer here is only aldehydes. Clear? Now let's go to the next question. The question here is a hydrocarbon with the formula C4H6 gives methane. They are telling the hydrocarbon will give methane. Okay, with the CH3MgBr. When treated with water in the presence of HgSO4 and sulfuric acid, it gives butan 2-1. So the same hydrocarbon gives 2 different products. But there is a very simple clue here. When Grignard reagent is present like CH3MgBr, if this wants to become methane, CH4, I am sure that alkyne should be acidic. Why? Because Grignard reagent on breaking, it will give you CH3 minus. The other one should be acidic, so that the H plus should come from there and it will become methane. So surely the alkyne should be acidic. So we know that terminal alkynes are acidic in nature. So from the given options, only one terminal alkyne is present, that is option 2. So with this clue itself, I can find the answer. That's it. Okay, those who need a complete explanation, you can see here C4H6. You can check with the formula CnH2n-2. From that I know it's an alkyne. Okay, we know terminal alkynes are acidic in nature. So I am taking but1 reacting with the CH3MgBr. So what will happen? This will remove the H plus, and Grignard reagent on breaking will give you CH3 minus and MgBr. Why? Because magnesium is an electropositive element. So it will push the electron towards carbon. That's why CH3 minus is coming. So these two will combine and you will get methane. And the second reaction, you can just verify it. When this is hydrolyzed in the presence of Hg2 plus ion, what will happen? The negative part of Markovnikov's addition will happen. The negative part of the addendum will go to least hydrogenated carbon. This will go to most hydrogenated carbon. So you will get something like this. This is ionizing. Then H plus will come here and you will get this one, and then OH minus will come here. So you will get something like this. Then what is happening? This particular species, if you see, this carbon is enol. Enol. Why it is called enol? Because to the same carbon double bond is present and to the same carbon OH group is connected. Such species are called enol. So what will happen here, sir? What will happen? Here keto-enol tautomerization will happen. That means the pi bond will come to here and the hydrogen will move to here. So that means you are going to get butan 2 on. You can see here. Clear? So that phenomenon is called keto-enol tautomerization. Please remember the name of this reaction is Kucherov reaction, but it is not mentioned in NCERT, but this is a very, very, very important reaction. Okay. Now let's go to the next question. I hope all of you could see. They are asking, in the given reaction, you have an alkyne reacting with some reagent A, forming a product like this. Then same alkyne reacting with some other reagent, you are getting a product like this. Here you can see bromine distributed at both sides. Here bromine coming at only one carbon atom. Then they are asking you the Kucherov reaction, what is the product of this one, and again Kucherov reaction for this one, and what is the product. So if you look at the options, I can easily say here these two options looks almost similar. First two half. Okay, from this I know that whether it can be 2 or 4. So I am not going to check with first option, if you see, you are doing bromine in CCl4. In that case only you have addition happening. So bromine would be added, anti-addition will happen. One bromine will get added here, then it will become double bond. Next bromine is added anti-additionally, then you will get a tetra-bromo compound. So you know that first one is bromine in CCl4. In both these options it is present. Next one, what you are doing, see, very important. You are adding HBr. When HBr is added, it is Markovnikov's addition. H plus and Br minus is present. So what will happen, sir? This will polarize, plus and minus will come here. Symmetric in nature, so don't worry about putting plus on the right side or minus on the left side. Again, H plus will come here and Br minus will come here. So you will get a species like this on first addition. Then what will happen? Again you are adding HBr. Then what will happen? This will again undergo polarization. Then you have a doubt, sir, whether I should put plus here or negative here. Please remember, bromine have 3 lone pairs present. We know in an electrophilic addition reaction, the intermediate is a carbocation. So usually the carbocation should be stable. Here, when plus charge comes here, I can easily say this lone pair will enter into resonance with the plus charge. So that's the reason why minus is coming here and plus is coming here. Then H will come here and Br will come here. That is how you are getting this product. Okay. So that means the first two option, bromine and HBr, it is present common for option 2 and 4. Next we need to do Kucherov reaction. Again the fundamental concept. You have H plus and OH minus. This will undergo polarization. Here also you need to see, this is not symmetrical. Where to put plus and minus? Here we will put plus here. Why? Because this is stabilized by hyperconjugation. 3 alpha hydrogens are there. Minus here. So you have H plus will come here and OH minus will come here. Again this is an enol. OH connected to the carbon and double bond connected to the same carbon. So what will happen? The double bond will come here and OH will come here. So you will get acetone. You can see. So while seeing this, you can see acetone is present in option 3, option 2. So I can say my answer is option 2 here. You can also do the other one. The mechanism again remains the same, but here it is symmetrical. So don't worry about plus and minus here. You can put it anywhere. Then add H and OH. Again, the concept remains the same. The double bond will come here and H will come here. So that means it becomes CH3CHO, acetaldehyde. Clear? I hope it is clear. We are going way quite fast, but I hope you could take the screenshot and you can enjoy it. Okay, next we have the next question directly from benzene. So benzene is treated with the HNO3 and H2SO4. We know it is nitration. Please remember, in nitration, HNO3 will behave like a base and sulfuric acid will behave like an acid. Why? Because very simple, sir. In order to generate the electrophile, how it happens? I have not shown here, but I can show you that. If you see HNO3, this is the structure. HNO3, this is the structure. Okay, this is HNO3 and sulfuric acid will donate the H plus and it will become HSO4 minus, which is stabilized by resonance. This H plus, what it will do? It will attack the lone pair of the oxygen atom. You can see here the H plus will attack from here to here. So what will happen? What product it will change to? I can show you that. So I am rubbing it. Okay, and this will become, you can see here, hydrogen will come here. Okay, and what will happen? One of the lone pair is lost, so plus charge will come. So this pair of electrons will move towards here and this will undergo heterolytic fission. So water is removed, along with you will get this pair of electron has shifted here. So you will get NO2 plus, that is my electrophile. So here sulfuric acid is donating the H plus. That is the reason why we say sulfuric acid will behave like an acid. And HNO3 is accepting the H plus. So that's why we call that as a base here. I hope you understood. Okay, yeah, that is the idea. Now let's see. So nitration happens. When nitration happens, what is happening, sir? NO2 group will come to the benzene ring, you know. Okay, but we have a problem. We know that here, see, NO2 group is a deactivating group because of minus M effect. So because of that, the next step, if you see here, I can show you. The next step, you are treating bromine with FeBr2. We know FeBr2 is a Lewis acid. So bromine will undergo heterolytic bond breakage and generate Br+. And this electrophile will have a less tendency to approach nitrobenzene because nitro group is deactivating benzene. Somehow it will go there and attack at the meta position and the reaction will stop there. Why? Because now you have two deactivating groups connected to benzene. Further deactivation with another bromine coming here, you cannot even imagine. That is the reason why you are getting a mono substituted nitrobenzene. So my answer here is option 1 would be the correct answer. Hope it is clear for you. Okay, so please remember, whenever deactivating groups are connected to benzene, continuous substitution with electrophile is almost impossible. Okay, now we go to the next question. The question here is very important question. Ethyl benzene cannot be prepared by. Ethyl benzene is this one. Cannot be prepared by Wurtz reaction. I can easily say answer is Wurtz reaction, because in Wurtz reaction we are taking alkyl halide, not a haloarene. Here in ethyl benzene you can see benzene is present. So I can easily say this is nothing but you have an aromatic compound here. Wurtz reaction can be used to prepare only alkyl halide, I can say alkanes. Okay, so with that itself I can say my answer is option 1, but we will go through the other options. You can see here Wurtz fatigue reaction that can be used. Here one aryl halide is used along with an alkyl halide, so you will get ethyl benzene. Magnesium in dry ether is used. Then the next method is Friedel-Crafts reaction. We know Friedel-Crafts alkylation. We take ethyl chloride here, ethyl chloride, and along with a Lewis acid. Lewis acid will break the bond heterolytically and absorb the Cl minus and become stable. You will get the electrophile, and this electrophile will attack benzene. You are getting ethyl benzene. Very simple, the fundamental reaction of benzene, ESR. Okay. Now let's go to the other important reaction. This usually many students will forget. That is nothing but my Clemmensen reduction reaction. This happens in acidic medium. Very, very important. So what will happen here? In zinc amalgam is present with HCl. So that will convert the methylene group to CH2 group. That is how you are getting ethyl benzene here. So my answer here is 1. With Wurtz reaction, you cannot prepare ethyl benzene. So my answer here is 1. Now let's go to the next question here. It's a very good question. Benzene can be obtained by heating either benzoic acid with X or phenol with Y. We need to identify what is this X and Y. Okay, so first you take benzoic acid. We easily know benzoic acid undergoes soda lime decarboxylation. Very, very important reaction. What is a soda lime? 3:1 ratio of sodium hydroxide along with the calcium oxide. That is called soda lime. So what is happening here? Na2CO3 would be eliminated. Na2CO3 would be eliminated and you will get benzene. And the other one with phenol, we know it's a very famous reaction given in the NCERT. Zinc, very good reducing agent. So reducing agent, how it will reduce someone? First it will absorb oxygen. The next step it can add hydrogen. So here it will absorb oxygen and forms zinc oxide, and benzene you will get. So please remember, mixture of NaOH and calcium oxide in 3:1 ratio is called my soda lime. So here answer is which one, sir? So the first one is soda lime and the next one is zinc dust. Option 2 would be my correct answer. Clear? Now we'll go to the next question. I hope you could see the question. Question here is, which of the following is the predominant product in the reaction of HOBr with the propene? It's again an NCERT reaction. So you have propene here reacting with the HOBr. Here most students have a doubt, sir, how you break this compound like this. Please remember, oxygen is a more electronegative compound compared to bromine. That's the reason why when it is broken, negative charge comes to oxygen and plus charge comes to bromine. Again, this is an unsymmetrical alkene. So what will happen? Markovnikov's addition. That means negative part of the addendum will go to least hydrogenated carbon and the other one will go to most hydrogenated carbon. So you will get an intermediate carbocation like this. Okay, then what will happen, sir? Then OH minus will come and attack at this one, and what you are getting? 1 bromo. You are numbering it 1, 2, 3. 1 bromo propan. At the next second position you have all propan 2 all. Some students may ask, sir, why you are doing like this? Directly you can come to the answer. Why I am doing like this? If you do like this, you will get an idea. This carbocation is stabilized by 3 alpha hydrogen and 2 alpha hydrogen from here. So with that concept also you can do it. You don't need to directly follow Markovnikov's addition. Okay. So my answer here is 1 bromo propan 2ol. 1 bromo propan 2ol is option 4 is my correct answer. Clear? Very simple. Now we'll come to the next question. The question is very important. C2H4, which is nothing but my ethene. and C2H2, which is nothing but my acetylene. That means an alkene and an acetylene can be distinguished by many methods are there. If you use sodium, we know terminal alkanes are acidic in nature, so alkynes will react with sodium. Even alkynes will react with Tollens reagent because it has silver present there. So silver will react, silver is a metal, so it can replace the acidic hydrogen and come over there. Here, but no Tollens reagent or sodium is present. Concentrated sulfuric acid, no. Chlorine in CCl4, no. Ammoniacal cuprous chloride solution. Why? Copper, metal is present. So your reddish brown precipitate, you will get it here. This can replace the H. But alkene will have no reaction. So in that case, my answer would be option 3. Clear? Yeah, ammoniacal cuprous chloride solution. So reddish brown precipitate indicates that an alkane is present there. So my answer is 3. Now let's go to this question, or I think this is the last question for the day. Question here is phenyl magnesium bromide reacts with methanol. Again, you have a Grignard reagent with methanol. Please remember, Grignard reagent on breaking, magnesium will always be positive in nature and negative charge will come over here. Methanol, alcohols are acidic, they can donate H+. So the H+ will come and attack the phenyl carbanion and it will become benzene. Very simple. So my answer here is benzene. Benzene is present only in option 2. So my answer would be option 2 would be my correct answer. Benzene with the MgO-MEbr. Clear? MgO-MEbr is nothing but Mg. You can see here MgO, methyl group is Me and this is Br. Clear? So yeah, there is one more question. We can see, I think some more questions are there. I think 1, 2, 3 and 4, 5. Okay. 6, 7, 8. Some more questions are there. We will go with that also. Okay, and then complete it. Okay, these questions are very important. Yeah. The question here is, we'll come to that. 1 minute. Yeah, question here is propene and propene can be distinguished. Propene and propene can be distinguished by which compound? Again, propene is a terminal alkyne. This is an alkene. I can easily say from this one, the Tollens reagent is present because it has ammoniacal silver nitrate solution. Silver is present. It can easily react with the acidic hydrogen. So I can say from this itself, option 4 would be my correct answer. So I can easily say, listen here, alkynes react with the Tollens reagent, ammoniacal silver nitrate solution. Terminal alkanes, it's not alkanes, terminal alkanes, because they are acidic, to form silver alkanides. Whereas non-terminal alkanes will not react with the Tollens reagent. So you can see the reaction here, Ag coming here, you are getting this product. And ammonia gas is liberated. Okay. Now, regarding Tollens reagent, it's a mild oxidizing agent. It can oxidize alcohol to respective aldehydes like pyridinium chlorochromate. Now Tollens test is given by whom? Aldehydes. They form bright silver mirror, and terminal alkanes, they form white precipitate. That is very important. This compound is white precipitate or create white precipitate. Okay, because of the silver. Clear? Then what for Tollens test is used? Usually it is used to distinguish aldehydes from ketones. Ketones under normal condition will not undergo oxidation with mild oxidizing agents like Tollens reagent. Okay, let's go to the next question. Which of the following will produce acetone? So again, you can see different types of reactions are given, but we have already done this question. Propene on Kucherov reaction will give you acetone fundamentally. So you can see here Kucherov reaction, CH3, C triple bond CH. So H plus and OH minus, the negative part of the addendum will go to least hydrogenated carbon, Markovnikov's addition, H plus will come here. So you will get something like this. This is nothing but anenol. So what will happen? The pi bond will come here and hydrogen will go here. So you will get what is called, you can easily see here, mechanism also I have written, you are getting acetone. Okay, so my answer here is which ones are? Easily I can say option 1 is the correct answer. And the second one, it is nothing but hydroboration oxidation reaction. Third one, it's again ozonolysis. You know, remove the double bond, put oxygen on both sides, acetaldehyde would be the product. Again, it is a Kucherov reaction on option 4. You will get acetaldehyde, but they are asking you acetone. Clear? I hope you understood. Next question is a very highlight question. It is expected for this year's NEET exam. The question is this one: hydrocarbon which is liquid at room temperature is. Usually many students will have a doubt: pentane, butane, propane, ethane. So please remember, directly it is mentioned in NCERT, this paragraph. Alkanes are non-polar molecules because of the covalent nature of CC and CH bonds. There is very little difference between electronegativity between carbon and hydrogen atoms, so they are non-polar. They possess weak van der Waals force. Due to weak van der Waals forces, the first four members C1 to C4 are gases. So that means up to butane it is gases. C5 to C17 are liquids. There is the clue. So from the given options, I can say 5 carbon atoms are present only in pentane. So I can say option 1 would be the correct answer. I hope you understood. Now we'll go to the next question. The question here is, you can see, in halogenation of an aromatic hydrocarbon, a halogen carrier is used, which is generally a Lewis acid. We know that. The main function of this reagent is to generate, very simple question, the main function of this reagent is to generate the electrophile. Here Cl plus, generally halogens are represented as X, so you can say X plus. So my answer here would be which one, sir? Option 3 would be my correct answer. Very simple. We'll go to the next question, very important question. Among the following compounds, which one has a zero dipole moment? We know that a zero dipole moment can come in two cases if the compound is non-polar, and a non-polar nature can come in two ways if the atoms does not have sufficient electronegativity or if their dipole moment gets cancelled. So here if you see from the given options, trans-butadiene, that means two bulky groups are on opposite side, so the vector will get cancelled each other, so I can say its dipole moment is 0. And the most important question here is, in NCERT, they are very clearly telling what is the dipole moment of cis-butadiene. Sometimes it can come as a question for identifying the wrong statement. Please remember 0.33 d by 0.33 d by is the dipole moment of cis-butadiene. This is present there as a statement in NCERT. They can ask you identify the wrong statement and give some other values. Okay, so this question is very important. Yeah, let's go to the next important question. Again, it is an ozonolysis. They are giving a cyclic compound here and they are asking you on this compound on ozonolysis will give you what compound. Very simple. What you need to do? Break the double bond, distribute oxygen on both sides. So what it will become? This will become double bond O. Okay, this will become HCHO. So you can see cyclopentanone and HCHO would be obtained as the product. So what is the answers are here? Option 1 would be the correct answer. Always the same methodology for ozonolysis, and this type of ozonolysis is called reductive ozonolysis. In our syllabus we need to learn only reductive ozonolysis. Why it is called reductive ozonolysis? Because you are using a reducing agent like zinc. There is another type of ozonolysis that is called oxidative ozonolysis. There we use hydrogen peroxide, but that is not present in your syllabus, so don't worry about that. Next comes the question. You have an aldehyde CH3CHO treated with zinc amalgam with HCl. Again we know it is nothing but Clemmensen reduction reaction, acidic medium. So what will happen? The carbonyl group will get converted to methylene group CH2. Then that will become an alkyne, that is nothing but ethane. So the answer here is what? Clemmensen reduction reaction. Clear? And the same reaction which happens in basic medium is called Wolff-Kishner reduction reaction. Always Wolff-Kishner reduction is more preferred over Clemmensen reduction, because since Clemmensen is happening in acidic medium, sometimes it may reduce some other side byproduct or some other side groups that is present in the compound. So always we prefer Wolff-Kishner reaction compared to Clemmensen reduction. In a Wolff-Kishner reaction we are using hydrazine. Okay. Yeah. Next question, which of the following reagents can be used to distinguish between but1-wine and but2-wine? Again, the fundamental but1-wine is a terminal alkyne. I can easily say this can be tested with sodium, Tollens reagent, or even ammoniacal cuprous chloride solution. Okay, ammoniacal cuprous chloride solution. So I can say here sodium is present. So option 1 would be my correct answer. Clear? Yeah. Let's go to the next question. Here you can say you can see acid salt is given. So again, whenever salt is given, we know it's a soda lime decarboxylation. So sodium hydroxide with calcium oxide, 3:1 ratio. We know 3:1 ratio we need to use. Okay, so what will happen, sir? Again, Na2CO3 would be eliminated and you will get benzene. It's a method of preparation of benzene. You can see here. Okay, Na2CO3 would be eliminated. You are getting benzene as the product. very important. These are all NCERT related questions. So that's it. This is our final question. So prepare well. If you have any doubts in any of the explanation, feel free to comment on the comment box. We will come with a very good chapter next time. Okay, and please subscribe our channel. You will get continuous important videos purely based on NCERT. Okay, thank you.